Thank you very much. And thank you, Dr. Soba. You've done so well to put this together. It's an honor. And thanks to the Dean of the School of Engineering, University of Lagos, for inviting me over. I do appreciate your courtesy. And thanks to my team that worked with Dr. Soba to put this together. I'm honored to be here with you all. And it's a pleasure to be back home. It's a pleasure to be back to my alma mater, and I love the faces I'm seeing, and I love the excitement, and hopefully we get this going, and I get to connect with you all. My name is Chukwu Zubelu Fulike. I'm a professor of engineering, technology, and industrial distribution, and I have a courtesy appointments as well in mechanical engineering and our School of Engineering Medicine at Texas A&M University. So Texas A&M University is the largest university in the United States of America. It's, I believe from the data from fall 2023, we have about 18,000 enrolled students. And the next to that should be the University of Central Florida in Orlando. So if you're looking for engineering, we have the largest engineering program as well. In fact, at about 8 years ago, we targeted reaching capacity of 5,000 enrolled students in engineering, and we surpassed that right now. So today I will be talking on revolutionizing additive manufacturing using melding and physics-based computational simulation with AI. Let me tell you more about me. So I've always wanted to. My dream was to study in the University of Lagos. So you all are very privileged to be part of this campus. I mean, that would be 3 decades ago that I was, no, 2 decades ago actually, I was trying to get into, start my undergraduate program in engineering. I took down, and as God will have it, the jam came out well. However, to get into University of Lagos, I did not know the needed further maths. So my secondary student advised me to take further maths as one of my courses at that point, subjects. So when I came for my registration, I was going to start my program. They told me that I can't enroll in like if I didn't do further maths. So I went to FUTO, where I studied materials and metallurgical engineering. And I told myself that I was going to graduate and become an architect one day. So after my full undergraduate degree, I came back and I registered for our M.P.E program, which is the Masters of Process Engineering under Chemical Engineering. I think now it's under the gas, petroleum and gas. Good, and that's how I got my UNILAG degree. So, and one thing, just so you know, as you know, is quote unquote state employee. Once you put my name on Google, you will see all my information. It has to be out there. The only thing you wouldn't see is my house address. So my email, all my information is out there. So all you need is my name and you can find me. I saw one of the students with M.P.E. So I'm the M.P.E faculty advisor for Texas A&M University. M.P.E is the National Society of Black Engineers. And I'm also an ASTM member committee for additive manufacturing technology, as well as the SME and Blacks in Advanced and Additive Manufacturing. As an alma mater, I thought it would be a honor to have late Dr. Ajayola, who was my project supervisor on the slide was very kind to me and very nice person to get to know. And he took care of that program from 2012 to 2014. I believe he passed in 2014. Okay. So Dr. Ajerola was my project supervisor as well. I'm doing this presentation, by the way, in honor of Dr. Ajerola, just FYI. So, and if you don't mind, if the dean doesn't mind, if we can have a minute silence for Dr. Ajerola, please, on your feet, please. Good. So these are some of my key research areas in advanced AI additive manufacturing. So I'm the director of the Digital Manufacturing and Distribution Lab at Texas A&M Engineering. And some of the things we do is trying to manage physics-based simulations with using artificial intelligence to optimize processes. Of course, in manufacturing processes, we would always have defects, so we want to reduce those defects, and we want to design new materials, fashion these materials specifically to change the way the manufacturing is done. So I do a lot of work in multifunctional materials and composites because I look at how I can signage new materials to, especially in additive. So I'm trying to use new materials for new processes or develop new processes for additive manufacturing. So now the question is, what is additive manufacturing? I'm sure this word is new to some of you. If you're in mechanical engineering, if you're in chemical engineering, if you're in material science, you will know or heard of 3D printing. So 3D printing is not a conventional quote-unquote manufacturing type. It is more for prototyping. However, it is a manufacturing process that creates objects by fusing the objects layer by layer. So we're going to have a layer by layer deposition. So it's unlike subtractive manufacturing where the materials are removed. For AM, it builds from ground up. And it does that by layer by layer from using a CAD file. So this is one of the type of printers that you can get from additive. This is an FDM printer, or you can call that the fused filament fabrication additive manufacturing, or FDM fused deposition modeling. So some of the key terminologies I want you to take out from this is computer-aided design. A lot of you in mechanical, chemical, material science, you're familiar with what it means. And layer by layer construction is just depositing materials or fusing powders in a hierarchical fashion to try to build an object from ground up. And that is what we're doing with 3D printing. Why is this important? You see a lot of advantages in customization and flexibility, meaning that you can have customized parts. So companies like Boeing, Boeing is a large manufacturer of jet engines, and in the United States, they have to be complex components, and these components have intricate and complex parts. So you can do that just subtractive manufacturing like molding or forming process. They need to be 3D printed. It reduces waste flexibility, meaning that you can have you are able to build what you need with the right material, right quantity of material that you reduce waste. And of course, it's used a lot for rapid prototype, meaning that you can have quick production of prototype, you should shorten design set times, and you can it should allow for flexible innovation. And you have on-demand manufacturing, meaning that the product can be manufactured on site. Take it, for example, Amazon, and they do this, and some other supply chain logistics companies.